Good morning, it's Mr. C with your Level 6 Math, and today we are looking at Lesson 19 in Saxon Math. Today we're looking at factors and prime numbers. So these are two things that we'll build on throughout this year. Some of it might feel like a review, but these are important concepts that we'll build on, so you need to know this. In Lesson 2, we talked about just having factors. Factors are any two numbers that when they're multiplied, they form a product. So for example, 2 times 3 is 6, the product is 6, the factors are 2 and 3. In 1 times 6, the factors are 1 and 6, and then 6 is the product. So we can see that 1, 2, 3, and 6 are all factors of 6. So any number is going to have a factor, be at least itself will be a factor of that number, and 1. So any number like 37 will be 37 times 1. Those are both factors, okay? But we see that for the number 6, all the factors that could be involved in it include 2, 3, 1, and 6. Those are all numbers that, if multiplied together in some combination, can equal 6. All right, so factors of a given number are the whole numbers that divide the given number without a remainder. We're going to use these a lot this year, finding the different factors of each number. So we'll dissect a lot of numbers. We're going to use 6 right now. So we can illustrate the factors of 6 by arranging 6 tiles to form rectangles. If it's not a rectangle, it doesn't work. So if you have to put one extra box to the side or whatever, then it's not going to be a factor. But here we can see 1 times 6, 1 row, 6 columns, has 6 boxes, and 1 times 6 is 6. Here we can take those same 6 tiles and do them in rows of 2. So we can take half of this and stack it. And then we get 2 rows and 3 columns, and that also works because it's still a rectangle. So we know that all the factors of 6 are 2, 3, 1, and 6. Now if we tried to do like 4 times something, it would be like 4 times 1.5 would be 6. Well, 1.5 wouldn't work into a rectangle. You can't just do a half a box there. So that's why these are the numbers that work. What are the factors of 10? So let's think. What numbers multiplied by each other will equal 10? We know that 1 and 10 always work, so always take the number by itself and times it by 1. And if there are no other numbers, we'll get to that in a minute, that means it's a prime number. But with 10, we know that from our multiplication tables, 2 times 5 also equals 10. So let's look at all the factors. 1, 10, 2, and 5. Those all go into 10. Now if we draw that out with the tiles, again, we can do 1 row of 10, or we can do 2 rows of 5. And so that's a good way to visualize it and think, can I make a rectangle out of this? What about 12? Now with 12, there's a lot more numbers. If we think of all our times tables, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and then of course the inverse, 4 times 3, 6 times 2, 12 times 1. So here we see that all the factors 1, 2, 3, 4, 6, and 12 go into 12. Those are all factors of 12, and if we draw those out, we can create rectangles as well. Okay, so when we look at the first 10 counting numbers or whole numbers and want to map out how many factors they have, 1 is only 1, 2 is our first prime number because we can multiply it by 2 and 1, 3 and 1 is also a prime number, 4 has 3 factors, 1 times 4 and 2 times 2. 5 is just 1 and 5. 6 we already did. 6 and 1, 3 and 2. So you can kind of see all the different factors that go into those first 10 numbers. Counting numbers have exactly 2 factors. Our prime numbers, like we discussed earlier. So if you can only multiply it by itself times 1, then it's a prime number. But if you can multiply something else into it, then it's not prime. So for example, for the number 9, 3 times 3 equals 9, and 9 times 1 equals 9. So that's not a prime number. But on 7, the only thing that makes 7 is 7 times 1. There's no like 3.5 times 2 or anything like that. So the only whole numbers that multiply to make 7 is 7 and 1, so that's a prime number. So the first 4 prime numbers are 2, 3, 5, and 7. What are the next 4? Well, let's see, after 7 we've got 8. 8's an even number. No even number except for 2 will be primed because you can multiply something by 2 to get that even number. So we know 8's not it. 9, 3 times 3 is 9, so it's not 9. It's not going to be 10 because that's an even number. So 11, yep, nothing else goes into 11, so that'd be the next one. 11 times 1 equals 11. You can do this by just writing all the numbers out, 11, 12, 13, 14, 15, 16, and then just started crossing off the ones that don't work. So anything that has a 2 in it, cross off. 2, 12, 14, 16, 18, 20, which they've done down here. Then we can think, since 9 is divisible by 3, we can take any multiples of 3, so cross off 12, 15, 18, 21 if it was still there. We can eliminate anything that has multiples of 5, so 10, 15, 20. And then we have our list of the next 4 because they're the only ones not crossed out. 11, 13, 17, 19. Then if we kept going, 21 wouldn't be 1, 22 wouldn't be 1, 23 would probably be the next one after that. So that's how you can come up with those. So we've got 11, 13, 17, and 19 are the next prime numbers. This is an activity you can do. It's going to take you a little while, but if you do it, you can put this sheet in your binder and have a list of all the prime numbers. So this isn't a bad idea. Just list out all the numbers from 1 to 100, and then like we just did, you can start crossing things out. So you draw a line through number 1 because it's not prime. Then you draw a line through number 2 and any even number. So you're going to eliminate half of the 100 numbers right there, all even numbers. Then you can start to circle the prime number 3 and draw a line through all the other multiples of 3. So just go up 3 at a time, cross out 6, cross out 9, cross out 12, cross out 15, and go all the way through 100 that way. Then you can take the prime number 5 and any multiples of 5, 5, 10, 15, and cross all those out. Then you'd go to 7, the next prime number, and cross all those out. You notice we're looking at all the prime numbers from 1 to 10. And once we eliminate all those, all the numbers on your list are going to show the prime numbers. So if you want a list of all prime numbers, you can create the sheet. It'll probably take you like 5 minutes, but then you have a reference sheet for forever. And that is our lesson for today. So we'll practice looking and identifying different factors of numbers, and then that helps us to figure out what prime numbers are. Good luck.